Welcome back everyone to the High Performance Fundamentals YouTube channel. Once again, I'm Lawrence Snyder and it's great to see you. In my last video, I provided what I believe to be a thorough yet general overview on what you'll need to know to make an informed decision when making your next battery purchase. It's basically a 12, 14, and 16 volt battery selection overview video. It's basically what it is. Well, in this video, I'm going to expand upon your lead acid battery options. And in the next video, I'll be expanding upon your lithium battery options. So before we get started, please take a moment to subscribe to the channel and click the like button. Once you've watched the video, if you find that this video content to be worthwhile, please take a moment to share this video with someone you think would also find it worthwhile. I appreciate you. Thank you for that. Now let's get started. Okay, so here we go. Lead acid battery options. Well, last time in the last video, what we talked about was your applications. There are three. Your SLI, your deep cycle, and your marine or RV battery. SLI meaning starting or starter lighting and ignition, also known as your starter battery. Deep cycle can also be considered like a power supply battery. And a marine RV is a dual purpose SLI or starter deep cycle battery. It's considered a dual purpose battery. I'm not going to get into that any deeper because that's not what this video is about. In the last video, we covered that in pretty great depth, so you'd understand that all of the batteries we're going to be talking about in this video and the next video all fall under one of these three application, headings, if you will. And we did basically do a pretty deep dive on that on the last video. So what I want to talk about today is your lead acid battery chemistry, your lead acid batteries. And what your options are when it comes to lead acid batteries. There's quite a few. There's not so many with lithium-based batteries, lithium-ion-based batteries, but for the lead acid batteries, there's quite a few. And I did touch on that quite a bit, but I didn't really get into great detail because I wanted to save that for this video. Last video was already tremendously long, or too long, really. So let's get into the lead acid battery types, and let's explain some basic differences. There's two real basic differences, and then we're going to expand upon that information also, okay? So initially, I've got them written here in different colors. I mean, not only, it gets your attention a little bit, but I did it in different colors for a reason. So you have your, what I consider to be your basic flooded lead acid batteries. And when I say flooded lead acid, all of these batteries are classified as flooded lead acid batteries. If you look it up, like FLA battery, they're all basically flooded lead acid, but I broke it down into what I consider to be something that's more intuitive or makes more sense, if you will. And what's in blue, that's with liquid electrolyte. So the electrolytic solution in the battery is in a liquid form or liquid state, okay? So, and those batteries would be your FLA, your standard or norm battery, your FLA maintenance free or advertised as maintenance free, your FLA sealed maintenance free. Once again, advertised as maintenance free and sealed, although not the same thing as an SLA sealed lead acid battery. We'll get into that and how that can be confusing. And then your FLA EFB battery or your enhanced flooded battery. All of the batteries in blue up here, they're all, in my mind, classified as liquid electrolyte batteries. It's in a liquid state or liquid form, okay? Now we'll move on to your AGM battery. And there's more than one type of AGM battery. That's your absorbed glass mat battery. And in that form, the electrolyte is suspended. It's put in the battery in a liquid state and absorbed by the absorbed glass mat plate separators. So at that time, it's no longer in a liquid state. It's not sloshing around, if you will, right? It's absorbed. It starts off liquid. It's poured in the battery literally as a liquid and absorbed into the separators or the absorbed glass mat or absorbent glass mats, also called that. And there are basically three basic types: your standard plate type, your spiral cell type, and your thin plate pure lead type. And there's more options now than there were, and I'm going to go over that in a little bit as far as different manufacturers here. And then you move on to your actual gel cell battery. In your gel cell battery, the electrolyte or electrolytic solution is in a gel form. Think of it like a jelly or a gelatin, right? It's no longer liquid. It's not necessarily absorbed into the glass mat, into the separators. It's in a jelly type consistency, okay? And that'd be a gel cell battery. All right, so that's the electrolytes. Let's go over real quick, like I was starting off here when I was talking about that, the two basic differences in batteries. Let's look at the vent system. you have what's known as an open vent system, or a free-flowing, continuously venting vent system built into the battery, so that each of the 6 cells can vent, literally can breathe out and in both, right? But it's not sealed in any way. Even though, like in this battery right here, it might be called a sealed maintenance-free battery, and an EFB battery, enhanced flooded battery, is also a sealed maintenance-free battery. They're sealed, but the vent system is not. It's not really a sealed lead-acid battery. It's sealed in a way that you can't get in there. You can't open it, right? They've basically made it to where you can't take the caps off. You can't get down in there to the electrolyte. So in a way it's sealed, but it's not actually a sealed lead-acid battery. It still vents openly. So not really sealed, even though they do advertise it as sealed. It's not a sealed lead-acid battery. It does not fall under that classification. Okay, so the batteries in blue, which are liquid electrolyte, they are an open, free-flowing, continuous vent system. In red, you have your AGM absorbed glass matte batteries and the gel cell. Both of these types, right? They have a closed vent system, meaning that the vent is not normally open. It's normally closed. Okay, it can open. It has to be able to open in case there's excessive battery pressure. If excessive battery pressure occurs, you don't want the battery to swell or split open or blow apart, right? Because that can happen, right? So it can't be permanently sealed. So what is it? It's a closed, it's still considered a closed or a sealed lead acid battery, right? SLA. SLA means sealed lead acid. VRLA, right? SLA, VRLA is a valve regulated lead acid battery. So what I want you to know is this. I've written them together here because they are the same thing. If you see SLA or you see VRLA, it's the same thing. You'll find that a lot, and I've found that a lot over the years with batteries. When they talk about battery nomenclature or how things are abbreviated or the acronym or the terminology, there's a lot of crossover, you know, when it comes to battery stuff. And if you watch the rest of these battery videos, you'll see what I'm talking about. How one thing can be called 2 or 3 different things. All 3 of which being the same terminal, the definition is the same, but a different heading or a different name or a nomenclature, if you will, right? So a closed battery is a closed vent system. It's called an SLA or a VRLA battery. That's known as a recombinant vent system. We'll talk about that in a second. So SLA is sealed lead acid. VRLA is valve regulated lead acid. So I'm gonna break this down. I got a little chart over here for you, and we're gonna break it down just a little bit further to make this a little bit more understandable. But I want you to understand, what are we venting? We're talking about venting, okay? You know, what are we venting? We're venting gases, okay? We're venting hydrogen, oxygen, and if you're overcharging a battery or overheating a battery, you're venting hydrogen sulfide. All right, so if you ever smelled a battery, like, man, it stinks. It smells like rotten eggs. You'll hear that all the time. It smells like rotten eggs. You know, what you have to know is that if you smell that, something is wrong. If it's being worked on, you're overcharging it. You're overheating it and you're overcharging it. If the battery comes in for service and you're a technician, or it's your own battery, and all of a sudden you start smelling like rotten eggs, there's a problem, right? It's not like, oh, no big deal. You know, it's come up with your own excuse. That's why it's doing that. There's a problem. Right? Either the battery is failing internally, right? You have a cell issue, or maybe the alternator in the vehicle or the generator is overcharging the battery, which is going to overheat the battery, which will produce hydrogen sulfide. You should not smell that, right? And if you're a technician out there and you have a closed sealed lead acid VRLA type battery, an AGM or a gel cell battery, and you're charging it and you start smelling that, the pressure inside the battery has gotten great enough to open that valve and allow it to start to vent. So understand this, you are ruining that battery, okay? You either are ruining it or you have ruined it, right? No big deal, we'll just let it cool down, it'll be fine. No, I'm going to tell you why you're ruining it or why you have ruined it. So, we are venting gases from the battery. All right, so you may or may not know this, a lot of you do, I'm sure. If you mix hydrogen and oxygen, 2 parts hydrogen and 1 part oxygen, what do you have? Water. Okay, so what is the electrolytic solution inside the battery? What is the electrolytic solution? The electrolytic solution is water and sulfuric acid, a mixture of the two. So if you're venting it, aggressively venting it, you're venting a lot of hydrogen and oxygen out of the battery, or water. So the electrolytic solution in a battery is being depleted, right? You are going to, if you haven't ruined it already, you're going to be either shortening the life of the battery or you've already ruined it, right? There's no way around that. Now, if that's a an open type battery, right, where you can actually get in there like a standard norm battery, where you can take the caps off and actually see the electrolytic solution, and actually you can service it, then you can fix it. I mean, you can actually, mostly fix it, or probably be able to take care of it. In that, what you'll find is, if you're smelling it, if you pull the caps off, what you're going to see is that some of that electrolytic solution is gone. And you can't leave the top of those plates down inside the battery exposed. They have to be submerged in electrolytic solution. So you need to add back deionized or distilled water, right, into that battery to top it off. And you can help correct that problem that it's been overheated. So that being said, so that's what we're talking about up here when we're talking about maintenance free. When they say maintenance free, they're talking about no need to service the electrolyte. Okay? Now, as I just said, since it's an open vent system and it's venting hydrogen and oxygen normally, it's open, it's venting, right? The battery is going through chemical reaction processes, and there are hydrogen and oxygen gases formed, and they're venting. That means that over time, in an open vent system, you're going to start to deplete the amount of water in that electrolytic solution, and the electrolytic solution is going to become less and less and less, exposing the top of your positive and negative plates, also known as your cathodes and your anodes, exposing those plates, which can be damaging, and actually will be damaging. So, if you have a flooded lead acid battery that's a normal electrolytic solution or a liquid electrolyte, you do need to maintain it. And here is what I call a advertised maintenance-free battery. They say it's maintenance-free, but it still has removable caps. You can still service it the same as you can the standard norm battery. It's really just advertising or marketing. And if you can maintenance the electrolyte, you need to. If you can see it and you can address it, right, you need to be doing that, or your technician needs to be doing it. Somebody needs to be doing it, okay? It just needs to be considered normal maintenance. It's not a bad thing. It's just a maintenance thing, right? But take the same type of battery and seal it. We'll glue the caps down. We'll glue the top of the battery down. We'll put stickers on the top of it. We'll do something that keeps you from pulling them caps off. So now you can't service the electrolyte. Well, yeah, we'll advertise it as maintenance free because you can't service the electrolyte. So there's no maintenance required as far as electrolyte's concerned. Still need to maintain a battery. But the electrolyte can't be maintained. Okay, so now it's maintenance free. Yay! Is that good? You make your own decision. I don't think it's good at all. I think it's terrible. I want to be able, if it's in a liquid state and I can maintain it, I want to maintain it. Right? There's a lot to be learned from the electrolyte, and we're actually going to make a video about electrolyte, believe it or not, because there's so much to know about the electrolyte in that battery, not just its chemical makeup, but what its job is, right? Anyhow, we'll make a video just about that. So, once again, going back to that, so basically we're venting gases, right? SLA means sealed lead acid battery. VRLA is valve regulated lead acid. Pressure regulator, pressure builds up, valve opens, it vents. That's why I say it's normally closed, because it can open. It has to be able to open. It's valve regulated. It's based on the amount of pressure build up. Gets to a certain pressure level, opens the valve, psh, out comes the gas, seals the valve, right? So it's one-way valve only out, not in, right? But you still vented hydrogen and oxygen gas, right? So basically you're depleting the water level in this sealed battery. You can't put it back. So never overcharge a sealed battery. If you overcharge it and you start to vent those gases, depleting the water content in the electrolyte, there's really no fixing it. You're damaging the battery. You can't go back and fix it. That's what I want it to be known. Okay, so once again, the electrolyte state. So we got two different categories, right? All of these batteries are lead acid batteries. Two categories: opened or closed vent system, and then the electrolyte itself. That's really what differentiates the two. And then we're going to get into much greater depth as far as like the construction of the battery, internals of the battery. There's more to it than just this, but it's like, look at this as like headings. SLI, deep cycle, marine. Then you got your liquid electrolyte. Then you have your suspended electrolyte. Then you got your gel type electrolyte. So these are like general overviews of what you're looking at, right? And like I said, as you break it down, there are two basic headings: open and closed vent system, and then the electrolyte state, right? And then the category it falls under: liquid, suspended, or gel form. All right, one more thing I want to throw out there real quick to you. Because we're going to be talking more about lithium batteries, you need to understand, as I get into the next video about lithium batteries, if you're interested in knowing the benefits of a lithium battery, you have to understand what energy density is, all right? And basically what that means is, if you think about a battery as stored electrical energy or available electrical energy, because a battery not only does it store electrical energy, it continuously provides electrical energy as it's being discharged. It doesn't just store a certain amount, you deplete it, it's done, right? These are what's known as secondary batteries or rechargeable batteries. So the process is ongoing. Yes, it does store a certain amount of electrical energy, but as you deplete it, the chemical reaction process continuously takes place and provides more electrical energy and more and more and more. So it's not just stored. It's stored and it's actively providing electrical energy. Both. Now, depending on how much the battery physically weighs, the weight of the battery, and not so much the case. The casing is going to be the same pretty much on almost all batteries. The casing is not going to really change much as far as its weight. Your external terminals, that's not really the weight. What we're talking about is the actual plates inside the battery, the plates or the cathodes and the anodes, what they're made out of, how much they weigh, how much energy they have for any given surface area. So, for example, if a battery, well, not as an example, let's just say this and we'll cut it short. So, if you physically weigh a battery, you weigh it, okay? And then you take a lead acid, and let's say you have an AGM standard, or a lithium iron, like lithium ferrophosphate or lithium iron phosphate, and you weigh them side by side, right? Let's say they both have the same amount of energy, right? Since the energy density of a lead acid battery is much lower than that of a lithium-based battery, this battery, let's say, weighs, just come up with a number, let's say this ends up weighing 22 kilograms or roughly 48, 49 pounds. You throw a lithium battery on it, similar capacity, and instead of it weighing 49 pounds, it might weigh, honestly, like 15 pounds. Because it has such a higher energy density, energy per given mass of internal battery, like I said, plates, anodes, the inner workings of the battery, if you will. It has much greater energy density. This number, like 30 to 60. 30, this is like I said, lead acid battery related, okay, not lithium battery based at all. Lead acid battery, 30 to 60. I've seen as low as 30. I've seen as high as 60 advertised. Common range is 30 to 40. So what we're going to do is this. Let's just create an average here, and let's say that on a lead acid battery in general, because we're going to be comparing this to lithium-based batteries, okay? These batteries do change in energy density depending on how they're internally manufactured. But let's say the average is 45 watt hours per kilogram or 45 watt hours per 2.2 pounds. All right. Let's just say that. Keep that in the back of our mind. When we talk about lithium-based batteries, I'll bring that up again. And you'll see that the difference is tremendous. And that's why lithium, one of the big benefits of a lithium-based battery is that it has great energy density and it's much lighter. So for the guys out there, not only who want that energy density, but they also want it to be lightweight or a smaller package. Maybe it's packaging, because if it has a much greater energy density, we can make a much smaller battery, so it's physically smaller and can fit into tighter places or cramped spaces, what have you. Where the bigger battery obviously is physically bigger to have the same energy density. It's going to be bigger and weigh more. So for performance applications, you don't want the weight, and for certain applications, you don't want the size. So there's a lot of benefits to lithium batteries. There's some definite downsides. We'll get into that also. But anyhow, that's what I wanted to go over to get started on breaking down, not going from applications to types. Now we're going to go ahead and expand upon this a little bit more. I think the first thing I will touch on is your VRLA in your sealed lead acid. That type of vent system, I want to expand on that just a little bit more, and then we'll move forward from there, all right? All right, so let's break down the SLA, VRLA vent system a little further. I've got a little chart here. So basically what I'm saying is it's a maintenance-free, normally closed battery vent system. All right, SLA, maintenance-free, sealed lead acid. VRLA, maintenance-free, valve-regulated lead acid. So what's its purpose? Minimized electrolyte or water evaporation or electrolyte depletion. We'd already talked about that a little bit, and that's the goal. It is what they call a recombinant vent system. What it means is simply this. As hydrogen and oxygen gases try to escape and they try to deplete the electrolyte of water, the hydrogen and oxygen gases are recombined in the electrolyte so that it doesn't actually escape. The level never changes. The water never gets depleted. So it's a recombinant vent system. It recombines the hydrogen and oxygen back into a water or a water state. H2O. All right. So recombinant functionality recombines hydrogen and oxygen gases with roughly a 95 to 99% efficiency rating, which is pretty good. I mean, it pretty much captures it all, pretty much converts the majority of it back into water, right? That is that's also known as active electrolyte mixing. So it actively mixes the sulfuric acid and the water in the battery. So the venting system is not just to keep the gases from escaping, but also to actively basically mix the electrolyte, because it needs to be mixed. Okay, it has a one-way pressure relief valve, normally set somewhere between 2 and 6 psi. So it's not a real high pressure relief, but under normal operating parameters, the battery shouldn't build a lot of pressure to where it's going to open it. It shouldn't be opening, basically, is what I'm saying to you. It's not that it never will open. It has to open for safety reasons, but it's not designed to open. It's not supposed to open then close, open then close. I mean, if that was the case, just making an open vent system, there'd be no need to even have it. It's just for safety reasons. That's why it's really there. Okay, so I'm just going to go over this real quick. In the last video, we touched upon this, and I'm going to. This was the general overview I provided in my last video. I'm going to expand upon this in a minute, which is one of the goals of this video, is to expand upon some of these definitions. But AGM and gel cell lead acid batteries. AGM, there's your standard plate type. It's known as absorbed or absorbent glass mat. Once again, AGM is absorbed glass mat, but you may see it called absorbent glass mat. Both of them are accurate. They're both the same thing. All right. No electrolyte in a liquid state. The electrolyte is suspended. Right. The separator plates inside the battery are made of a glass fibrous material, like fiberglass. They absorb or suspend the electrolyte. So it's not a liquid state. It's not sloshing around in the battery, right? So the electrolyte is absorbed into the glass mats that also act as the plate separators. Utilizes an SLA VRLA vent system. That is for your AGM and gel cell batteries. They are SLA sealed lead acid, as opposed to an advertised sealed maintenance-free battery. It's not the same thing, okay? Monitoring or servicing of electrolyte is not possible nor required. Since it is a recombinant system, and theoretically little to no water should be escaping, so it's not depleting the electrolyte, maintenance of the electrolyte should not be required. It truly is maintenance free. All right, it's one of the benefits of an AGM or a gel cell type battery, is it truly is maintenance free when it comes to the electrolyte. Batteries have to be maintained. They all need some sort of maintenance. They need to be cleaned, inspected. The terminals need to be cleaned, corrosion cleaned from them. Make sure they're tight. Batteries do require inspection. They do. You can actually perform testing on the batteries to see if it's degrading over time. There's all kinds of things you can do as far as maintenance on a battery. But when it comes to the electrolyte, an AGM or a gel cell battery, the electrolyte does not need to be maintained. Okay? So then you move on from there. A different type or a different form of AGM battery is your thin plate pure lead battery. Odyssey brand. It's made by EnerSys. They have this acronym AGM2. I think it's just their way of saying it's different than a standard AGM battery. I don't know that AGM2 means anything other than that. I believe it's kind of like something that they came up with. I could be wrong about that, but I think that all that's denoting is thin plate pure lead. All right. That being said, Optima is now making a battery also that is a thin plate pure lead battery. That battery, I have to look that up real quick, but I can't remember what they call that now. Power something. It'll come to me in a minute. Anyways, so Optima is making a thin plate pure lead battery, and I do believe Interstate Batteries has a line of thin plate pure lead batteries also. So it's not just Odyssey, the Odyssey brand, or the one that's made by EnerSys. There are others. Okay. Then you get into your spiral cell batteries, which is obviously still an absorbed glass mat battery. It still has an absorbed glass mat separator, right? The cells are in a spiral configuration, right? And it is an SLA VRLA type battery also. Optima makes the Optima brand battery, which I think a lot of us are probably familiar with, is a spiral cell battery. I have also found out that Exide is making a battery. It's called their orbital battery, kind of like picture like a circular design. Same exact design criteria, circular or a spiral type cell design. It's like I said, that is made by Exide also, and they call it orbital. All right. So the plates and separators are formed in a circular or spiral configuration. Then we move on to the gel cell battery. The gel cell battery is a lead acid SLA VRLA battery. It is not an AGM design. It's not. It's a gel cell battery. The electrolyte is not suspended. It's in a form of a gel. The electrolyte is bound in a silica gel matrix, a gel-like consistency. So that basically goes over your AGMs, what makes them different from standard flooded lead acid batteries, and we're going to touch on that. Okay, so flooded lead acid batteries, general overview. All right, so flooded lead acid batteries, you have an FLA standard or norm. That is a maintenance type, requires monitoring and servicing of the electrolytic solution or the electrolyte. It's not advertised any other way. It is a maintenance type. Sometimes it may not say maintenance type. It'll just say you won't see maintenance free. You won't see that advertised. There'll be nowhere on the battery or in the literature where it says maintenance free. The caps will be exposed. In my last video we went over, I showed you a lot of images of maintenance type batteries and what they look like. But nonetheless, it does require monitoring and servicing of the electrolytic solution, or a standard or norm is what it's called. Then you get an FLA maintenance free. It's advertised as maintenance free. I call it maintenance possible. What that means to me is that it's marketed as maintenance free, even though monitoring and servicing of the electrolytic solution or electrolyte is possible. And in my mind, not only possible, but highly recommended. If it is an open vent system and you can monitor and service the electrolyte and test the electrolyte, then you should be doing that. If you're not doing that, then, well, you got the wrong type of battery. Maybe you need to get into something that truly is maintenance free. But those batteries, the maintenance type batteries, what ruins them the most, or what they suffer from the most, is lack of maintenance. When people do maintenance them, they do maintain them properly, they can last a very long time. But unfortunately, they don't get maintenance. They get neglected. Especially these days, a lot of your younger technicians are not really accustomed to maintenance type batteries, because so many cars now come with AGM or EFB or sealed type batteries that can't be maintained, that they're not used to doing it. When I was growing up, of course, every battery required maintenance, and it was just it's part of your everyday life. I mean, it was charging, maintaining, testing, adding distilled water to batteries. It was common. Even batteries, we'd get batteries from the parts store back in the day, and they would come without electrolytic solution. You had to add it to the battery. It came dry, and you had to add this electrolytic solution, charge the battery, and then it was ready for service. Right? That was common. Nowadays, it's not so common. The batteries are still out there. A lot of them aren't getting maintained. They're not. It's unfortunate, because it is a good quality battery, but they get a bad rap as being inferior because they're not getting maintained. Okay? So, it's advertised as maintenance free, which, I guess is, from the battery manufacturer standpoint, as long as it's making it through the warranty process, if it lasts 3 years and it's out of warranty and you got to buy another one, oh well, you got to buy another one. It can last a lot longer if you maintain it properly. That's why I call it maintenance possible, and it really shouldn't be advertised as maintenance free, but they are advertised as maintenance free, and that's unfortunate. All right, so from there, you get into your flooded lead acid sealed maintenance free battery. Like we had said, that's not an SLA battery with a VRLA system. It's not that. It is literally just sealed. They don't want you going in there. It makes it difficult. In a lot of cases you can, but if you do anything to the battery that like you cut the stickers on the top of it, you maybe cut away some glue to get the caps off, your warranty is void. So yeah, it may not be permanently sealed, and yeah, you probably can get in there, but I don't know if I recommend it or not. So that's an SMF, sealed maintenance-free battery. Monitoring and servicing of the electrolytic solution or electrolyte is not possible in all intents and purposes. And then you have your FLA EFB battery. It's a sealed maintenance-free battery also. It is an enhanced flooded battery. It is a better battery. It is not constructed the same internally. It's not the same thing as the others. These other three, whether it's an FLA standard norm, FLA maintenance free, or a maintenance or sealed maintenance free SMF, these are the same battery. Basically, if you're comparing them to each other, you're looking more at like what are the ratings of the battery, what's the cranking amps, the cold cranking amps, the amp hour rating, the reserve capacity, and that's how you compare them to each other. Other than that, same basic battery, right? But when you get into an EFB, enhanced flooded battery, it is exactly what it sounds like, enhanced. Right? Also sometimes known as an extended flooded battery. Like I said, different manufacturers, I don't know why they do that. But this battery was actually invented by Exide, and it's called an enhanced flooded battery. That's what it is. Okay? It's prevalent in vehicles equipped with the engine start-stop system. The vehicles, when you come to a stop, the engine shuts off, and you go to take off, you hit the gas, the engine starts back up, and away you go. Because of the fact that you are continuously utilizing the battery to crank the engine over, stop, crank the engine over, stop, crank the engine over, stop. It's just non-stop. Crank, 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 crank. Every time you turn around, you're cranking it over. The battery is actually designed internally differently so that not only can it tolerate that discharge, it can also recharge rapidly. Because since you're discharging that battery all the time, every time you turn around, you're discharging it. It's got to be able to recharge rapidly, or the battery's going to end up discharged and going to be dead before you know it. So they are designed differently internally. You'll also find them on vehicles with regenerative braking, like mild hybrids or hybrid electric vehicles. The vehicles that, like, when you're slowing down, there's actually like the vehicle is, even though you're not hitting the brakes, the vehicle is slowing down kind of aggressively on its own. And in that way, the braking system is designed to recharge the battery. It's called regenerative braking, and that battery is designed to tolerate that. Right? It's one of the vehicles that you will find that battery in. In most cases, if you have regenerative braking, you have a start-stop system anyway. And like I said, a mild hybrid vehicle is going to have a combination of the two in most cases. So that's not uncommon, but I just wanted to bring that up as another place where you will find that EFB type battery. Okay. It is a more affordable alternative to an AGM battery or absorbed glass mat battery. In most cases, your very best FLA liquid type maintenance-free battery is going to be cheaper than your AGM battery, and your EFB battery is going to fall somewhere in the middle. In most cases. I mean, there may be cases where you'll find AGM cheaper than EFB or vice versa. I mean, I'm not really sure. That could be a thing. But in most cases, it falls in between the two. The EFB tends to be more expensive than your standard liquid lead-acid battery, and they're a little cheaper than an absorbed glass mat battery. And monitoring and servicing of the electrolytic solution or electrolyte is not possible. Right? It is an open vent system battery, but it is sealed. It's not designed to be opened up. And like I mentioned, you could get in there and service it. If it was my own vehicle and the battery was out of warranty and I thought it was necessary, I would open it up and get in there and I would service the electrolyte. It wouldn't bother me a bit. Knowing that if I did that under warranty, while the battery was still under warranty, I might void that warranty. So something to take into consideration. All right. So from there, what I'm going to do is I'm going to clear the board off. I'm going to go ahead and start comparing these batteries side by side to give you an idea of, more of a technical idea as to what makes one different than another, better, or at least a better understanding as to why you would pick one over the other. And maybe you decide to go with the standard norm FLA maintenance type battery, and maybe you decide to go with the very top of the line, most expensive AGM battery you can find. At least you have an understanding as to what you need to know to make that decision. All right, let's go ahead and define in a little greater detail your options in lead-acid batteries. And in doing so, we'll do some comparisons. Initially, I'll start off with basically your liquid lead-acid batteries, and then get into some AGM. And then I'm going to get rid of these two, and we're going to get into some of your AGM options because there's more than just one. Okay, so initially, lead-acid batteries, as far as liquid electrolyte, once again, I drew those in blue to designate liquid electrolyte. And this is your basic flooded lead-acid standard or norm battery, or your flooded lead-acid maintenance-free or sealed maintenance-free battery, or advertised as such. So what is that? Basically, that is going to be our basic battery, our entry-level battery, if you will. It is the most affordable. It is the most available. It is the most common. The reason for that is that the majority of the manufacturers of automobiles, will use that type of battery because it is most affordable, and it is a good quality battery, and it does give you a long service life if it's maintained properly. But like I said, most affordable, and it's most common. So most affordable, most available, and most common. It does have the shortest life overall. Its life expectancy tends to be somewhere in the 3 to 5 year range, which in my experience over all these years, 5 years can be a bit of a stretch. I mean, I've seen them last that long. I have. But it seems to me like more often it's 3 to 4 than it is 5. That's been my experience. They're known for acid leakage and spillage. Like I said, it's a liquid electrolyte. They do leak and they do spill. You can spill them. Around the posts or the terminals where they come through the battery case, it's common for it to get wet with battery acid. It corrodes your terminals. corrodes the battery cables. If it leaks out onto the battery tray, it'll eat the battery tray. It'll eat the inner fender of the vehicle. It can be very damaging. So they're prone to external corrosion issues. And once again, that is your open vent system. Like I said, if you maintain this battery properly and you are maintaining it, you're on top of it, and you catch the leakage and you take care of it, or you catch the corrosion and you take care of it, you can keep this in check. And this can be a viable option. It's most certainly an entry-level battery. It's most certainly your most affordable and most available battery. So let's move on to the same basic battery design, an open vent system, liquid electrolyte. This is the enhanced flooded battery, as we had spoke about. Like I said, sometimes called extended flooded battery. It is less affordable. It is the least available of the three. Reason being that the manufacturers are putting these in vehicles. A lot of your mild hybrids, like I mentioned earlier, or your hybrid electric vehicles. There's a difference between mild hybrid and hybrid, right? There's a difference. Regenerative braking systems, start-stop systems. They're using these batteries, and in some cases they're not using EFB, they're using AGM. So the number of vehicles that these are in from the factory, the number of vehicles or the different battery physical sizes is limited. So for example, if you have a standard flooded lead acid battery, you say, hey, I want to go ahead and upgrade, I want to put an EFB battery in there. You may find that the dimensions of the battery that you need, it may not be available. That's what you may find. It's not available for every battery group or battery size rating. It's not available for that. So of the three, it's the least available. And because it's the least available, the reason it's the least available because it's the least common. It is enhanced, and so how is it enhanced? It has reinforced plates. The positive and negative plates in the battery, also known as your cathodes and your anodes, they are reinforced. They're more robust. Okay, they're designed to handle, last longer, be more durable, can take vibrations. It's a more durable plate system. Period. They have an increased heat tolerance, so they're not affected by heat nearly as much. They have an increased rate of charge and discharge. So basically what this means is that the rate at which the battery can not only accept the charge, we'll call that energy recovery, but also deliver stored electrical energy, right? That rate is approximately 3 times greater. And think about the fact, like I mentioned earlier, that the battery is being utilized repeatedly to start the vehicle, start the vehicle, start the vehicle, start the vehicle. That's a lot of drain on the battery, and it happens repeatedly. It's very frequent. So now we've got to recharge that battery over and over and over. So the rate at which it charges and discharges has to be rapid. It has to be able to discharge a lot of energy in order to start the car on a regular basis. It also has to be able to recharge itself rapidly so that it doesn't become gradually more and more and more discharged to where it's actually completely discharged. So it has to be able to accept a recharge rate, a faster recharge rate, which is what it does. And it is, just like the other, an open vent system. It's not a sealed lead acid battery. It is a sealed maintenance-free battery. Sealed in that, like I said, they don't want you getting in there, like I mentioned earlier. And it is, but it is an open vent system. All right, so moving on to the AGM battery. And basically these are, in a nutshell, getting better as we go, right? So AGM, absorbed glass mat. It has a glass mat separator. It is the least affordable of the bunch in most cases. This is going to be least, more expensive than this one. It is readily available, so if you have a battery that is standard liquid electrolyte battery and you want to replace it, you can almost assuredly find an AGM replacement that will fit your application. It's very common. So it's readily available. It is quite common. It is designed to be leak-free. Now, I've worked on a lot of cars with EFB batteries in my life. I've not experienced a whole lot of leakage here. But it is liquid electrolyte, and it can leak. It can leak around the posts, and it can leak if it develops a small split or something. It can leak. It's possible. Or where the case is actually assembled, the top and in the bottom of the case where it's assembled, it can leak there. They're designed to be leak-free. They are very vibration resistant. The AGM absorbed glass mat, and the reason they're so vibration resistant is because in these batteries, this one not as much as this one, but the design is such that there are 2 lead plates, positive and negative plates. Basically, the positive plate is lead dioxide, also known as lead peroxide. That's what the surface of the plate is. The negative plate is sponge lead or spongy lead, right? So basically 2 soft metals. Lead's very soft. And the metal of the lead on the negative plate is also spongy lead, so it's porous, right? So they are a soft metal. In between them, you have a separator that's a porous separator, and you have a liquid electrolyte. Basically, they're submerged in a liquid electrolyte. So picture liquid electrolyte moving around in the battery, right, in the cells, and lead plates hanging down in that electrolyte. Now, electrolyte is diluted sulfuric acid. So now we have a diluted acid in soft metal plates, and we have the liquid sloshing around. So how can we improve upon that? Well, let's take that separator that's between those plates. All batteries have to have a separator because the positive and negative plate, they cannot touch each other. If they touch, the battery becomes electrically shorted, and that cell, that portion of the battery is dead. It'll kill that portion of the battery. So basically, they cannot touch each other, so you have to have a separator so that, like I said, so they don't short against each other. So in this case, there is a separator, but it's just a porous divider. In this case, your electrolyte is absorbed into that separator. That glass mat, the electrolyte's absorbed into it. And the battery is constructed in such a way that the plates the separator's sandwiched in between the plates, and those plates and those separators are compressed and then inserted into the battery. So now the electrolyte's not sloshing around, the plates aren't hanging there freely, they're actually compressed. So now the liquid electrolyte is now suspended, and the plates are not sloshing around, moving around, so you don't have this sulfuric acid moving all around these plates, right, literally sloshing around. It makes the battery very vibration resistant, so the plates aren't really affected so much by the vibration, and it gives you a longer life. The battery tends to last longer, it becomes more durable. Because that acid, although essential in the electrochemical reaction that takes place inside the battery, that acid is essential. It is corrosive. It is acid. And we're talking about soft lead. So the design is such with the AGM design that it is very vibration resistant. Since it is leak free, you have tremendous mounting options. The only mounting option that you don't have is inverted. You cannot take the battery, let's say your posts are sticking out of the top, you cannot invert the battery so the posts are sticking straight down. But other than that, you can mount it on its side, this side, that side, whatever, however you want to mount it, you can mount it, just not upside down. You cannot do that with these batteries. You lean these batteries on their side, they're going to leak, right? So you have a lot of mounting options, and I have used these batteries in situations where I've mounted them sideways because I had to. But they didn't fit. I had a smaller battery and had to mount it sideways to get it into a certain application. So I have mounted them sideways. They last a long, long time like that. This AGM battery, and including the AGMs, all the AGMs, and the gel cell batteries, they are the SLA VRLA closed vent system that we discussed. And this battery, just like this one, has an increased discharge and recharge rate. Now, that being said, you will find that if your car has an EFB battery, and you need to have it replaced, you may find that they recommend an AGM battery. So, that being said, a lot of manufacturers are recommending an AGM battery as an upgrade to an EFB battery, right? I don't know for sure that in every case it truly is an upgrade. I would say that it probably is a wash. And maybe in some cases it would be an upgrade. But I'm going to tell you from my experience, the EFB battery is definitely a good quality battery, a real step up from the regular battery. Is it better than an AGM battery? I would say that it's better because it doesn't have the leakage issues, it doesn't have the external corrosion issues. So in my mind, that's a big plus. In my own personal vehicles, I have a couple of vehicles that I've had over 20 years. And those vehicles, after the first battery that came in the vehicle, which was a standard lead acid battery, once that battery needed to be replaced, I put AGM batteries in it. I've been running them ever since. And both of my vehicles that I've had for over 20 years, neither one of them has had battery terminals replaced, battery cables replaced, battery boxes. There's no corrosion in the inner fenders. Nothing has occurred. I mean, you look down at my battery box or my battery cables or my battery, it looks brand new. I mean, it really does. You can't tell I've had a battery in there for 25 years in one case. But I have. And that's why I got away from it. There wasn't any really other reason other than the life expectancy, which, by the way, in these batteries, instead of 3 to 5 year life expectancy, you're looking something more like 5 to 7. And in this situation, I would say that on average in my life, I've experienced 4 years. You'll get 5 occasionally. Sometimes you do only get 3. But 4 probably is a good average. And I've definitely gotten on the AGM batteries, I've gotten 7 years. I have. In particular, the spiral cell batteries, I've gotten 7 years. And even then, the battery just got weak. It didn't just let me down. It didn't go out one day and it was just letting me down like I had nothing. Like it was just dead. It was just getting weaker and weaker, and finally I pulled the battery before it caused problems and put a new battery in it. But it never actually let me down. So that's what I've got for these right now. So what I'm going to do is I'm going to get rid of these two, and we're going to expand on the other AGM options. And I'll stick those right here, and we'll explain those. So here we go. AGM battery types. Okay, your standard AGM battery. your spiral cell, also known as your orbital cell or circular cell, and your thin plate pure lead. Odyssey, one of the terms they've deemed it as AGM2 or AGM squared. Optima has deemed that type of battery a pure flow battery. It's just branding as far as I'm concerned. So that is your thin plate pure lead, your spiral or circular cell, or orbital cell, which is orbital cell is a branding by Exide. That's what they call it, and Optima calls it a spiral cell. So we've already talked about the AGM quite a bit, but once again, all of these batteries are glass mat separators, because that's what they mean, absorb glass mat. We all know that the electrolyte in all of these batteries is a suspended electrolyte. We talked about that. We also know that all these batteries are going to be the SLA, VRLA, normally closed vent system. All of them are like that. They all have roughly the same life expectancy, 5 to 7 years. Some claim more, but in my experience, 5 to 7 years is probably pretty accurate. So from there, the original or the most common AGM plate style battery, the one that you'll find pretty much anywhere they sell automotive batteries or batteries for boats or motorcycles or what have you. It's a standard plate type battery. It is the most affordable of the bunch. It is readily available. It's quite common. It is like all of these. They tend to be leak free, or they're designed to be leak free, I should say. They are all vibration resistant, some more than others. They all have a variety of mounting options, although inverted is not okay. Upside down is not okay. But that's our basis to work off of. So from there, let's go to our thin plate pure lead AGM2 or pure flow battery. It is the most expensive of the bunch. It has the highest capacity rating. It has a 15% increase in lead plate surface area. Okay, now, if you know anything about lead, you know that it's becoming very expensive. Lead batteries, lead-based batteries are getting more and more expensive all the time. Since it has more lead plate surface area inside the battery, it is going to be more expensive. Since it has more lead plate surface area inside the battery, it's going to have a higher capacity rating. That is the way it is. Okay, that's great. So what does that mean to you? We had said earlier that lead acid batteries tend to have on average, energy density of about 45 watt hours per kilogram, or 45 watt hours per 2.2 pounds. That hasn't changed. Okay, that's on average. But what's happening here is this, that if you have a given footprint, if a battery has a given footprint, whatever dimension you want to say, 6 inches by 9 inches, 6 inches wide, 9 inches long, 152 millimeters wide, 228 millimeters long, however you want to go about, talking about that. But if you compare two equal batteries, same height, same width, same length, the one with the thin plates is going to have a greater battery energy capacity, right? And because of that, here's why. So if you have a given space inside a battery where the cell is located, 12-volt battery's got 6 cells, 14-volt battery's got 7 cells, 16-volt battery's got 8 cells, which means those are compartments down inside that battery. So if we were to make each of the positive and negative plates throughout the battery thinner, right, of a higher quality material but thinner, we could put more plates in there, couldn't we? Instead of like 4 thick positive plates and 5 thick negative plates, if we use thin plates, we might could get 10 of one and 11 of the other. So the actual surface area, the surface of that plate, even though the plate's thinner, the actual thickness of the plate is thinner, the total surface area, the area that is of the lead material, right, whether it be lead dioxide or lead peroxide or sponge lead, and the sulfuric acid, that surface area where the two interact, the electrolytic solution and the surface area of the plate, if that surface area is greater and more of them, so your total surface area is greater, then you're going to have a greater electrochemical reaction, basically meaning that chemical reaction is going to produce more electrical energy, right? More stored or available capacity. It's just a function of how a battery works, the electrochemical reaction and how it works. More lead surface area equals more contact with the electrolytic solution equals greater energy, greater capacity. That's the way it works. Now, is there a downside to that? The downside is this. If you have two batteries of equal surface area, the actual area of the battery, the case itself, not what's internal, not the guts like we're talking about, but the actual case, right? Two batteries, same size, fit in the same location, same mounting, same everything. Externally, they look identical. One's TPPL, one's standard AGM. This battery is going to be heavier, right? Period. It's going to have a greater capacity, for sure. It's going to be heavier, absolutely. You put more lead in the same area, same space, it's going to be heavier. And it is heavier. And it's more expensive because you got more lead in there, right? It's just more lead, right? So what I'm saying to you is this. It's not just hype. It's not just them saying like, oh, it's thin plate pure lead technology. It's more expensive and it has greater capacity and da-da-da and all this advertising mumbo jumbo, right? The reality of it is that it does have more lead plate surface area. It does have a 15% increase. It does have a higher capacity rating. But the downside, if you're a racer or somebody who's worried about the weight, you know, how much is this thing going to weigh, right? Not so much the cost. It's going to be a downside for you because it's heavy. They are heavier. If you have a 15% increase in lead plate surface area, that's going to be 15% heavier. I mean, you know, numbers don't lie, right? But other than that, right? So is there anything, do I have anything negative to say about that? Okay, other than the fact that it's heavy, right? Okay, they even advertise that it has a lower self-discharge rate. What that means is, you know, you get a battery, you set it on a bench, you let it sit there long enough, it'll go dead, right? It's called self-discharge, and the rate of self-discharge. How long does that take to happen? Does it take 6 months, a year, 3 weeks, 2 years? How long does it take? They claim that it has the lowest self-discharge rate of any of the AGM or standard lead-acid batteries, right? I don't know if that's true or not. It may be true. I don't know that for a fact, but it's definitely claimed by everybody who makes TPPL type batteries. And as I mentioned earlier in this video, AGM2 is an Odyssey. That's their Odyssey, like their trademark, if you will. Optima calls it Pure Flow. But Interstate Batteries, they have thin plate pure lead batteries. I'm sure others do too. These are the two I'm most familiar with, or that promote it the most, if you will. You know, they really promote it. So anyhow, I don't see a negative to this other than it is more expensive and it is heavier. You know, but it's all as far as like if you want a battery that fits the same footprint, you want more capacity, you know, more stored energy, increased reserve capacity, increased amp hour rating, increased cranking amp rating, right? But the same footprint, then this is a really good option for you. Now, let's move on to the spiral cell, orbital cell battery, right? So I have a lot of experience with these batteries. I've been using these batteries for, let me think about that a minute. Probably, I think when I first came across that battery, when it was first introduced, at least to me, that probably was like 1994, 5 maybe, something like that. Maybe before that, possibly even before that, maybe even 92-ish. I'm not really sure about that. But I have used those batteries all of that time. From then till now, 30-some years, I've been using those batteries in all my personal vehicles. My race cars, my wife's car, my wife's truck, my truck. I've been using them for all those years. And I've had people say that, oh, they're this, that, and the other, and they got negative things to say about them. And there are things you need to know when you pick an AGM type battery in general, or a spiral cell or a TPPL battery. There are things about caring for those batteries that you need to be aware of, right? As long as you understand what you need to know to properly care for one of those batteries, believe me, I'm here to tell you that they last me, and I've had many of them over the years. I even have them on my engine run stand that I used to run engines on. I use them on that. I used to use them in my golf cart. I mean, I use them in everything. You know, and they last me 7 years at least. And then I take them off. When I take them out of my vehicles, and this is no lie, and nobody's telling me to tell you this. I'm not getting paid to tell you this. I don't have a, you know, there's no advantage for me to tell you this, none. But the reality is this, that when I take them out of a vehicle, I take them out because they're not performing. Maybe the vehicle's starting to crank a little slow. You know, I noticed that, you know, like when I check the open circuit voltage after the vehicle is sat, it's lower than I expect it to be. I'll take it out of there. I'll put them on my engine run stand. And I got one on my engine run stand right now. It's been on there 10, 12 years, maybe 12 years. It'll still crank an engine and run it on my engine run stand, but I don't want it in my vehicle because I can't trust it. But have they ever let me down? Like just totally like let me down? No, that's never happened. So I've got a lot of good to say about them. But let's talk about, let's compare them. That's what we're here for. So once again, glass mat separator battery, sure enough. As far as cost, this battery is the most expensive. This battery is most affordable. This one would then fall in the middle, be an average cost, I would say. It tends to have the lowest capacity rating, and it's the lightest. Why would that be? Well, think about what we said about a footprint. Imagine if you have a rectangle, okay? And in that rectangle, we put 6 round cells, right? 3 here and 3 here. to make up a 12 volt battery. Look at the void between each one of those spiral cells, right? If you look at the side of a spiral cell battery, you'll see that there's open pockets in the side of the battery. Well, if we're using thin plates and compressing them and squeezing them down inside a battery to use every last, increment of space that we have to get the most capacity, if we leave voids all around the spiral cells, we're going to have less capacity, which in fact they do tend to have the lowest capacity rating. If weight it means much to you, they are light. They're the lightest of the bunch. Makes sense, right? You got voids, that's air, right? So that's going to be the lightest, right? They are leak free. I can tell you from experience, they are very vibration resistant. I've never had one, like I said, fail. I've had all types of batteries in my life fail. Just all of a sudden, you go out, you drive, let's say you drive your vehicle to work, or a customer's driving a vehicle to work. They drive to work, they leave work, they go out, get in their car, they open the door, lights come on, they get in, they turn the key, nothing. Get out of the car, nothing. No lights, nothing. Just done, right? Open circuit. Internally, open circuit in the battery, no voltage, no amperage, no current capacity, no energy, done, right? Never had that happen. Never. Not here or here. Now, I'm not saying that they can't happen. I've never had it happen. Your lower cost AGM batteries, the most affordable AGM plate style batteries, I have had that happen. In the rare occasion of my own personal vehicles, when I went away from that and went this route, that 5 to 7 went down to about 3.5, 4. It really did. I went back. I don't want that. I don't want to be stranded. So I went back to that. Okay, so anyhow, mounting options, all of them can be mounted like we talked about. You can mount them on their sides. Just can't mount them upside down, or what they call inverted. Can't mount them inverted. But all of them are really good options in my mind. I don't like dealing with liquid lead acid. In my lifetime, I've worked on a lot of high-end German import cars and, high-end American domestic cars, Cadillacs and Lincolns and what have you. And there have been times, and this is absolutely no exaggeration whatsoever, I want you to understand that the corrosion from the lead acid batteries cost the customer a couple of $1,000s. Now, I understand that sounds ridiculous, but if the corrosion crawls down the cables, it's not just on the terminal. And you see it, you open the hood, and you see the corrosion on the terminal, on the cable. But if it crawls into the insulation and starts working its way over to, let's say, the power distribution center, which is under the hood, or down to the starter motor, or up inside the firewall, it starts to creep, right? A lot of these harnesses, you can't get a section. You can't get a piece. You gotta get the whole entire vehicle harness. And in some cases, some of these harnesses, especially on German cars, some of the conductors are aluminum. So splicing in replacement harnesses can be very difficult. Now, you can do it to an extent, but it's difficult, and you got to be careful about liability when you start doing that. But it can range into the thousands of dollars. For years, I've gotten away up on a personal level. I don't want to deal with the corrosion. I've had to fix corrosion issues for customers and had to charge customers over the years, in many cases, to do nothing more than fix corrosion. And then replace the battery, and it needs a battery, and it needs terminals, and it needs cables, and the battery box is rotten out, or the inner fender's got a hole in it, or there's no paint left, so it's rusty. It's like on and on and on. I've about had my fill personally, on a personal level, of liquid lead acid batteries. I've about had all I can stand, But by all means, if you're on top of it, you stay on top of it, right? Keep an eye on it. You see corrosion, take care of it, right? Address it. Don't let it get out of hand. It is a viable option. It's a very good power source. It will work for you. It's just not for me anymore. Anyhow, so that's what I've got there. I'm going to move on to gel cell batteries, and then we're going to talk briefly about 14 and 16 volt options and what you need to know about that if you're going to run a charging system or if you're going to be charging those batteries. A couple things you got to know. So gel cell, 14 and 16 volt batteries, and the things you got to know about that. All right then, so let's get into gel cell batteries. In most applications, gel cell batteries are going to be used for deep cycle purposes. Marine and RV mainly is where I see them. Sometimes in a dual purpose starter lighting ignition, SLI starter type battery combined with the marine RV battery. Sometimes you'll see a gel cell battery in that application, but I mostly see them or have seen them in my life more in deep cycle applications as a power supply or a power source. Gel cell batteries are just that, like we talked about earlier. The electrolyte is in a gel form, a silica gel matrix, right? So it's a gel type consistency. They are just like the AGM batteries we've been discussing. They are very resistant to leakage. They are highly vibration resistant. They have mounting options similar to the AGM batteries. Basically, in all intents and purposes, they are a viable option to an AGM battery. The one takeaway that the one thing I want you to take away is this: that because it's a gel, because the electrolyte is in a gel form, if you overcharge the battery by accident, your charging system has an issue and you're using it as a dual purpose battery, so it's in a vehicle with a charging system, and it overcharges the battery, what can happen is that gel, where the gel contacts the surface area of the plates, the positive and negative plates we talked about, or the anodes, or the cathodes and the anodes, you can actually get boiling, right? So pockets will form in the gel. Imagine a little air bubble, a little pocket, right? Where it had boiled, it's no longer, that gel is no longer in contact with the surface of the plate, right? It does not heal itself. Once that occurs, it's occurred. Now, what you have to understand about the electrolyte, and we're going to have a video based on just electrolyte, just battery electrolyte, because there's so much to know about the electrolyte that I think it deserves its own video. But one of the things it does is it helps to cool those plates, right? It needs to be in contact with that plate. Also, the electrochemical reaction that takes place between the electrolyte and the surface of the plate, the chemical reaction taking place to create voltage and electrical energy, it becomes non-existent on the surface of the plate where the gel is not contacting it. So the efficiency of the battery goes down. The plate itself can overheat and start to actually flake away or erode, if you will. So if that battery undergoes overheating, overcharging, it can suffer consequences that you can't correct for. It just becomes, it doesn't become like you've ruined it automatically or it's completely dead, but its capacity may start to drop. Its longevity may start to drop. Right? It is the one thing in my mind about a gel cell battery that I've kind of stayed away from in my lifetime. That is the only reason that I've stayed away from them. There is no other reason. They tend to be more on the pricey side. They're not as cheap as your standard AGM battery, but they are similar to like a TPPL battery, thin plate pure lead battery. So I really wouldn't say that they're like cost prohibitive necessarily. They are durable. A lot of good, 100%. You got to be careful about overheating them. That's been the biggest takeaway for me, and one of the reasons I've stayed clear of them. If you have a different experience or you feel differently about it, please put it in the comments and let's talk about it or let's discuss it as a group. That's been my biggest takeaway. I don't have any other reason not to recommend it to you, other than that. You know, it may be a very viable option for a deep cycle battery or a dual purpose battery. So there's that. Okay. So let's talk about. Instead of a 12 volt battery, why would you want a 14 volt battery, or why would you want a 16 volt battery, and what are the things you got to be a little careful about there? So let's talk about a thing called voltage sag, voltage drop or voltage sag. Okay, and what that means is this: let's say that you have a standard AGM or you have a standard liquid lead acid battery in your car, and you're monitoring voltage as you crank the engine over. As you are starting the car, you're monitoring the voltage at the battery. Let's say that the battery, before you actually started to crank it over, let's say it was 12.6 volts, and you start to crank it over. And it's crank. You're monitoring that voltage, and it's going to drop. That voltage is going to come down. But depending on the battery's capacity, you know, the amperage load from the starter motor, you know, the actual current draw, it's going to come down, you know, I can't tell you exactly how much, but let's say it were to come down to 11 volts or 10.5 volts, right? Let's say 11. So you say, okay, we went from 12.6 to 11 while cranking. Imagine now that you had a 14 volt battery. Now that's common. That voltage sag, that voltage drop, that's common for lead acid batteries. Okay, that's not uncommon. So let's say the battery is now a 14 volt battery, and it undergoes the same conditions. The same thing happens. Well, now cranking, you may find that it's 12.5 volts. It went from, let's say, 14.7 fully charged, 14.8, and it went down to 12.8 or 12.5. Well, that's what the normal 12 volt battery is before you start cranking. So what happens is this: the performance of the starter motor will be increased. It'll crank faster. It will act like the battery is like on steroids, right? It's got like a little boost. Like, dang, that's something. Like, what a starter, you know? Like, nah, it's the battery, right? So, okay, so the downside to it is this: if you take out a 12 volt battery out of a normal car, you know, or truck, or whatever, and you drop in a 14 volt battery, the alternator on the vehicle or the generator is not designed to charge a 14 volt battery. As an example, fully charged after the car is not running and the battery has sat, right, and the voltage is stabilized, fully charged battery, 12 volt battery is going to be about 12.6 to 12.8 volts. Okay, a 14 volt battery is going to be about 14.7 to 14.9 fully charged. Okay, when the alternator is charging that 12 volt battery, it's charging that battery somewhere around 14 to 14 and a half volts. So if you were to check the battery voltage while the car was running, you're going to see somewhere between 13 and a half and 14 and a half, but while it's charging the battery, 14 to 14 and a half is what you're going to see. Okay, so now think about that. That's what the alternator is designed to do. Well, that's not even the voltage of a 14 volt battery fully charged, let alone charging voltage, which has to be greater. So now what you need is, instead of 14.7 or 14.8 volts, you may need, what do you need, 16 volts, right, to properly charge that battery, you know, somewhere in that area, 15.7, 15.8. And just so you know, that voltage, that recommended voltage, can be found out from the battery manufacturer. They will specify what they consider to be like vehicle charging voltage. So what is that? So the problem is this: your alternator, your generator won't properly charge that battery. What do you do about it? They do make alternators, universal alternators usually, for performance applications where you can actually adjust the voltage regulator. So if you want it to put out 15.8 volts, let's say the battery manufacturer says, we want 15.6 volts, that's what we want, or maybe a range, you can adjust it for that, okay? And then your alternator will put out the correct voltage. And at that point, really, there's not much of a negative to it. I can't say that there's going to be a big negative. Now, when you move into a 16 volt battery, you got to be a little more careful, because the same scenario occurs with the voltage drop and a voltage sag, and you go from, let's say, 16.8, 17 volts fully charged, and it might drop down to 15 volts while cranking, you know, or 14.5 or whatever. So yeah, oh, good. But that battery may require a charging voltage of 18 volts or greater. Okay, now what you have to know is that a lot of your onboard electronic systems, your computer control systems, your fuel injector drivers, your ignition coil drivers, they have a safety, and they're not all the same. And believe me, they're not all the same. So don't get carried away, don't get crazy. But they can cut off when they reach the 18 volts threshold. So if you put a 16 volt battery in a standard passenger car, truck, or what have you, or boat, and you put in an adjustable alternator, or one designed to charge a 16 volt battery. Let's say you just buy a 16 volt alternator. It's designed for that. It's not adjustable necessarily, right? Then all of a sudden it gets up and charging, things start going haywire. Car don't act right, starts shutting down, weird stuff can happen. So in that realm, in my personal opinion, a 16 volt battery is made for performance cars only, race car applications only, where you are charging the battery either externally, no alternator, no generator, you're charging it externally, or you're regulating it to a point where, let's say your cutoff voltage for your injector drivers or your ignition drivers, your coil drivers, is 18.5. You never go over 18. You're regulating it. You're on top of it, right? When you charge the battery, a standard battery charger is not going to charge a 16 volt battery. As a matter of fact, a standard battery charger is not going to charge a 14 volt battery either. So it is viable. There are reasons why you would go to a 14 volt battery. There are reasons why you would go to a 16 volt battery. You know, I've done it, right? I know plenty of people who have done it. But keep in mind that it's not a drop-in. You're not going to drop that battery in and be like, yay, everything's awesome, right? It's not going to be like that. You're going to have to make some changes to the vehicle on a 14 volt side. On a 16 volt side, it's really not even a viable option. Not on a drop-in application for a standard, your daily driver. You know, you got a hot rod, you drive it every day. 16 volt battery is really not an option for you. 14 volt battery might be a good option for you, but like I said, there's some things you're gonna have to do. But on a 16 volt battery option, if you're gonna go that route, then you're gonna have to buy the specified battery charger to charge it properly. If you do get an alternator for the vehicle, it's gonna have to be an alternator that is designed for 16 volt batteries. And then from there, if you have cutoff voltages of 18 volts or whatever, then you better make sure that that voltage from that alternator is regulated down to less than 18 volts at all times, right? You're going to have problems, right? Okay, so that being said, I think that pretty much wraps up this video, is what I wanted to say. So like I always do when I end these videos, I like to put in one little personal note, and that is very simply this. Do yourself a favor, do everybody a favor, right? And I try to live by this. Take time to be thankful, right? To show a little kindness, right? And to try to remain humble, okay? It's basically words to live by. It's what I try to live by. So with that being said, thank you very much for watching the video, and I certainly hope I'll catch you on the next one.